Hello teachers and hello everyone. Today our group gonna present about our project, which is the multiplayer TicTacToe over ROS2. And we are from group 7. And here is our members. My name is Chum Kimchhun, Sopanha, and the last one is Mengly. Here is our agenda. First we have the project overview and objectives. Second, we have overall ROS2 architecture. Next, we have game logic. We have node structure implementation. We have custom messages, interesting algorithms, technical highlights, visualization, simulation, result demonstration, challenges, lesson learned, future improvement, and the last one is conclusion with demo. So let's go start with the project overview. So we have the distribute real-time gaming. So what's that? So it's a synchronous two-player game operating via the ROS2 inter-process communication IPC across distant terminal instances. So we have a turn-based IPC that's synchronized game state published to share the ROS2 topics. We have dual terminal players, the player X and player O, executed in isolated shell processes. And we have the real-time state sync. We have the instant topic updates preventing race condition. Next, we move to the dual visualization and input. So it provides the dual feedback through the instant terminal CLI, updates, and optional 3D or YIZ2 marker rendering. So keyboard direct mapping, we have key 1 to 9 mapped to 3 times 3 board in this. For all Y as a 2 3D markers, we have the visualize X and O measures in the simulated 3D space. You can see the pictures. We have 1, 2, 3 until 9, X 2, 0, 4, X 6, so and 8 and 8. Now let's move to the functional and technical requirements. So here I included the table right here. We have the category, requirement description, technical mechanism, and target metric and status. So first we have it is functional. It is the input key mapping. It is non-blocking raw terminal keyboard capture key to 9. And we have instant move input. Second, it is also functional, custom ROS2 message, TicTacToe move.msg interface container, and board state array 9. And third one, it is also functional. It is the dual visualization, CLI, ASCL rendering, plus the OY as a 2, 3D marker array, and real-time synchronization. And the fourth one, it is non-functional. It is state update rate, ROS2 timer callback loop execution. It is bigger or equal to 20 Hz update rate. And the last one, it is also non-functional. It is the system modularity, the coupon publisher, and subscriber node architecture, zero hard lock, and loose coupling. Let's move to the overall ROS2 architecture. So here it is the OQT graph. As you can see here, we have the transform listener IMPL, and we also have the game engine. Let's go to the game state, and let's go to the board visualizer. And it's also go to game state again, and it's gonna go to the player node. And the player node gonna move request into the game engine. And here we have like 4 nodes like here. We have player 1 node, which is the terminal 1 input key to 9, symbol as X. And we have player node 2, symbol as O. And we have the game logic node, validate turn order, compute 3 in a row, winning logic, update board array 9. And we have the OY as the 2 visualization node, translate board state 9 into visualization SG marker array for OY as the 2 rendering. And so we have the topic, TicTacToe move, message, TicTacToe move.smg, and topic, the TicTacToe game state. So the last one here, it is the orchestration launch file. It is to automated node launcher, parameter manager. And we call it the ROS2 launch TicTacToe game.launch.py. So to simplify running our game, we create game.launch.py. So instead of opening the multiple terminals and running nodes individually, the launch file use the ROS2 Python launch system to spawn our backend processes at once. So it uses node from launch ROS.actions to launch the state and player moves. It launches the visualization node, which subscribe the game state and generate 3D marker for both geometry and piece placement. It uses the executed process to automatically open the VIZ2, rendering the 3D game board immediately upon startup. So note that player terminal instances are launched separately in their own interactive terminals, so player can use keyboard control directly. And that is the end of my responsibility. So now I will hand over the presentation to the next teammate, who will walk you through our game logic. Thank you for everyone for your listening.
Thank you, Kimchhun, and hello, teacher and everyone. I'm mainly and I will explain about game logic. For our game logic, we start on an ongoing state and wait for player input. First, it will initialize game board and ROS2. Afterward, it listens to the player move to request on move request, and then it will check for move valid. If it doesn't is it not valid, it will reject and then take the same player request again. And if it valid, it will update the game board and game state. And afterward, it will publish that update state and on game state. And then it will check the condition if the player has won yet. If they hasn't won yet, it will check again if the board full yet. If the board also has not full, it will switch current player to another player. And then if the current player meet the condition to win, it will publish win result on the game state. Or if the board is full, it will publish the draw result on the game state. And then it will wait for the player whether they decide to play again or leave. If they play again, it will look to take the refresh and take the user input again. And if no, it will end the game session. And in our game system, we have three nodes. We have game engine node where it will control the game role and the game state. Basically, the engine of the game it decides when the player wins yet. And then for player node it receives the keyboard input from player and then send that move onto other node. And then visualizer node it displays the both in ROS2. Here you can see three nodes here where the game engine have 6 main functions, and in player node we have 3 functions, and in both visualizer we have state called by only one function, and in the engine node we have 6 functions here. We have handle move, it is to handle the move from player and check the player turn and validate the cell and update the board. And for handle continue here, it handle the yes no response from the user whether they want to continue the game yet or decide to end the session. And then for the check pending is just to check whether the player agree to play it. If they agree, it will trigger the reset round. And for reset round here to reset the board and publish the new game. When the player decide to play again, it will refresh the last game board. And then the check game state. The check game state to check when the board is already at the meeting requirement to win yet or not. This is to detect the winning line, like 3 diagonal line to win, or when they draw full board to get the draw condition. And then for the publish state, this is to the publish game state into other node, like to send it to visualizer node. And then for player node, we have 3 functions: render board, where it will show the current board in the terminal and print the prompt based on the game state. And then for the keyboard loop is to take the user input from the terminal and then send that input or move or response message to other node, continually reading the player input from the keyboard and decide. And then the send function is to take the send number from the keyboard loop or response code from keyboard loop and then publish it onto the move request. This is to send the player action into ROS2 message and send it to other node like game engine. And then we have visualizer node where it visualize the game. And we have one function here, state callback, where we take the game state and then publish it as marker array or visualization marker array. And it is to convert the game state onto the always marker. And now to the custom message, we have 5 custom message here. And for both state and selected cell, it is to store the cell value. It has 9 cells, and then this is to store the chosen cell, which cell has chosen and which cell has yet chosen. And then we have player symbol to identify the player, which one is O and which one is X, and then the game status to tell whether the game is still ongoing or it's ended. And then the winner, the string winner is just to carry the message like winner text and score text and the system message when it in who is the winner. And the reason we do it this way is that the node will synchronize, the message will synchronize with all node when taking action without needing to make many nodes for every action. Like if when the game state is updated, the game status and selected cell will send the same message to all 3 nodes without needing to create many separate nodes. It's synchronized at the same time. And that's all for my part. Now I will let Panya handle the rest from here.
Okay, so hello teacher and hello everyone. So this is my part for our project today. I will be going forward from section 6 to the demo and also the challenges that we face. So right now, let's focus on the section 6 first. So an interesting algorithm and technical highlight that I apply in this project. So first, it is coordinate transforming 1D array to a 3D space. So you see that we have done the terminal X and O on the terminal. Yeah, we just have the 1D array, but right now we turn it into array with board. So we need the 3D Cartesian coordination of X, Y, and Z. So here is the game piece of it. Yeah, and also warp it into a matrix of from 0 to 8 in order to physically grade the accuracy of spawn maker. And we also have added the quaternion for the X marker. So we have created the X into a large chunk piece of X. So we use 2 interesting inserting cube. We have quaternion them by rotating them into exactly 22.5 degree, or we can say pi divided by 8. Yeah, so in the opposite decision, so it will create the X. Yeah, and next we're going to talk about section 7 about the visualization and simulation. So here is the visualize or the array board that I have created. So here is the visual market array. So we have the thick wooden board. So the brown one is the wooden board, and we have the O, which is the cylinder, yeah, the chunk of cylinder, and also the X as the intersected cube. And also we have the dynamic jump score using marker text view facing the update, like the winner. We have the score if X1 win or O1 win, how many are their score, and also how many X and O are going to draw. Yeah, so the challenges that I faced in making this is managing a unique marker ID to ensure that the piece didn't override each other, and also configuring the WSLG UI environment into successfully output the Davis display. Welcome back to the demo. So I'll be doing the demo for the our code project. So here I have opened 3 terminals for my demo. So each one for each command. So first we have to change the user from Ubuntu 22.04. Yeah, and we have the source install and the setup.bash, and also here we have the command for each one running. So first we have the export display ROS2 launch TicTacToe game launch and py. So this will trigger the game node and game manager node, and also the Ravis board. Yeah, so let's run this. So first we have to run this one first. Okay, good to go. Okay, done. Okay, so for this, so here we will be loading the Ravis 2 board. So we will be getting back to that. So next we're gonna run the X player command first. Okay, so this is the X player command. Okay, so let's run. Okay, so successfully. Okay, next one is the O player. Okay, so this is the O player. Okay, so let's take a look. Okay, successfully. So without further back, let's go into it. So as you see here, it is the Ravis board that we have not set the time grid yet, so we have to set this first. Okay, so as you can see, we have the board right here. This shows a 3D plane. Yeah, in order to see the actual board or actual 3D, so we have to open this first. So we have add, and then we click the marker array and OK, and click this one and open. As you can see, here is the topic that we have. So when we try to play the game, okay, so here's the X. So as you can see, we have the X on the terminal right here, and also with the O turn is going, so fine. So let's see, will our Rabbit board we updated the board. Okay, so you can see right here our code is been updated. It's just upside down. Okay, so you see it will display it is a play X turn, and also the X is 0 and O is 0 and draw is 0. So it is initialize the point. Okay, so we can see that in the Ravis board and also in the terminal here, it looks exactly the same. Okay, so it looks exactly the same. So here is we have to play a game to see if it actually works or not. So I click number 7. Okay, so this is a play X turn and play O. Okay, 4. Okay, 6. Okay, 8. Okay, 2. Okay, so let's take a look at what do I do? Okay, so let's go to 9, and this one let's go to 3. Okay, so it's reloaded. The X is win. Okay, so you can see the X is win, got 3 by here. Yeah, so it will say that if you want to continue or not. If you write yes, okay, so if this one goes yes, it will continue the game. Yeah, we restart the game. And also it is turn for the O to move first. So here O, and also X, yeah, 9, yeah, and 4. Okay, and this one will move to 7, yeah, and see if O will be gonna win with point 6. Okay, so the logic is here that if one player choose yes and another player choose no, the program will be asking, I really want to leave. If they are surely that they want to leave, they will go to leave together. Okay, so game session is closed, and thanks for playing. Okay, so control C to exit, and also for the other board, yeah, it will display the final game. And take a look at our Ravis board. So our Ravis board will load the message of game has ended, final score X1, O1, and the draw is 0. Okay, so we don't have the exactly draw right here, but we'll test it. Okay, so next we'll be testing that if the draw is actually work or not. So right here we have player X to move, so we click 1. Okay, it will load it to 1, and for O it will click 5, and it will go into 5, and for X we will click 8. Okay, so for Y we will click 7. Okay, 7, 8. It is X turn, right? Okay, so it is O turn. Oh, sorry, it's O turn 7. Okay, so 3, and O turn we will press 2. Okay, so which x will reply by 4 for 4, and O will reply by 6, okay, and X will reply by 9. Okay, so it is a draw. Let's take a look at the game board. It's actually work. Okay, so you see right here, okay, it is actually a draw. So we see that the D here, it's updated into the 1, so it is a draw. And the score, we keep the track until we leave the game. So here the question will be asked if you want to leave or not. Click Y for yes, click no for no. Okay, if both said no. Okay, so it's both said no. Okay, so if we load it, the game is closed. And here is also the game is closed with a draw for 1. Okay, so this is the end of our demo, and I think, yeah, it is a pretty interesting project that we have to learn more about the Ravis, get to know more about the Ravis board, and also the node, how to manage it. Okay, thank you for. We were going to talk about the lesson that we have learned and the challenges during we are doing the project. So the technical difficulty that I have here is I don't know, like the visualizer, the Redis board is running, but it's not connecting to the RQT graph. So it's need me to identify the missing topic, subscription, and also ensure all node are launched simultaneously via the game launch Python. Yeah, integrate the code together in the game launch.python, and also I still have another challenge of not connect to display. Yeah, so we have some error while doing launching the ROS2 GUI tool. Yeah, so what have I do? I have configured the X server. Yeah, display the routing for Windows subsystem for Linux. And what I have learned here is that the power of ROS2 to publish and subscribe the architecture of decoupling game logic from the graphic. Yeah, I have learned how to make the matrix, the 3D code in Ravis, yeah, and also design and neuralize the custom ROS2 messages. And next, section 10 is future improvements. So I think that we still got a pretty big room for the update. So in the future, I would like to do the advanced AI opponent, yeah, implement the minimax algorithm to create an unbeatable single player mode node. Yeah, we have a body as an AI to play with us. Yeah, we have the physical hardware integration, connect the game into a real multi-robot system. Yeah, the robot arm can physically move block into a real grid. Yeah, that's a big dream. Yeah, and also we can create whether some mobile or web UI which have the XO game, and also maybe a multiplayer game, not just XO but any other game too. Yeah, so that is my future update and what I want to do in the future. So here's section 11, which is we will come into our conclusion. So the summary of our achievement is that we have successfully designed, developed, launched, and distributed the multi-node ROS2 software with the real-time 3D rendering. And here is our GitHub. You can check it out. And also, we have the reference from ROS2 documentation, API, Python, library of ROS2, Ravi. We have the custom message, and also the flowchart, and also the Windows subsystem for Linux. Okay, so merci pour work and good. Thank you for your time and listening. I hope you have a great day and see you again. Bye bye.